Okay, so for today's lesson, we're going to start talking about something called probability. And we have three objectives. We're going to learn how to find the probability of an event occurring. So we might answer a question like, what is the probability that this will happen? We're going to tell whether an event is likely or unlikely to occur. We'll also talk about the complement of an event. There we go. Okay, probability is defined as the likelihood. Oh, that didn't come out very nice. Let's try that again. I'm going to switch to a new color too, because that looked weird. The likelihood that something will happen. So probability is just like the chance. Likelihood, another word for that would be chance. The chance that something will happen. So for example, if we have some coins, we might want to know, what's the chance that I'm going to roll a head or tail? For a dice, what's the chance that I'm going to roll a 6 each time I roll the dice? If I have a bunch of letters in a bag, I might want to know, what's the chance that I'm going to pick a U out of this bag of letters? Okay, those are the kinds of things we're figuring out when we do probability. And what we're going to talk about first is called theoretical probability. Okay, this is on your second page. Okay, theoretical probability looks like this. You'll see the letter P with something in parentheses, and the something in parentheses is the event you're looking for. To find the probability that an event is going to happen, you take the number of favored outcomes over the number of total outcomes. Okay, so here's an example. What is the probability of getting heads when flipping a coin? Well, the event is getting heads, so we would write this as P with the word heads in parentheses. This is what we're finding, the probability of getting heads. And the big letter P just means probability. How many different outcomes are there when we roll a coin? Two. So there are two possible outcomes. We could get heads or tails. The only favorable outcome is getting the one that we want to know the probability for. So rolling heads is our favorable outcome. Is getting heads. So the probability of getting heads, there's one way to get heads, so I'm going to put 1 divided by 2 total outcomes. So we're using the equation up here. Favored outcomes, there's 1. There's 1 head on the coin. There are 2 different pictures on the coin. So the probability of getting heads is 1 out of 2, which we can also write as 0.5, or we can write it as a percent. What percent would that be? Kaylin? 50%. So we can write probabilities 3 ways, as fractions, as decimals, and as percents. Okay, here's another example. What is the probability of rolling an even number when you roll a 6-sided die? So the event is we are finding the probability of getting an even number. You can just put capital P and then put the word even in parentheses. How many possible outcomes are there? When we roll a die, how many different things can we get? 6.
2.
The answer is 6. No, there's 6. So when we roll a die, most dice are standard 6-sided. I don't have one in here, but most of them are 6-sided. If it gives you a dice problem, you assume that there's 6 sides unless it tells you there are more. So there are 6 possible outcomes. We could roll a 1, a 2, a 3, a 4, a 5, or a 6.
7, 8, 9,
Let me fix that 3.
12.
Okay, out of these outcomes, how many of them are even numbers? Out of my list, Spencer?
3.
3. So 3 of them are even numbers. What are the even numbers, Spencer?
2, 4, 6.
2, 4, and 6. So to find the probability of getting an even number, we put how many are even on top. So there are 3 that are even over 6 total. What do we get when we do 3 divided by 6? Spencer?
1/2.
We get 1/2. And what does that look like as a decimal?
0.5.
0.5, and what percent is that?
50.
Good. So we have a 50% chance of rolling an even number anytime that we roll a die.
We're doing the same one on this page.
Okay, that's one for you to try. So the next
That's
slide
confusing now. How-
is one for you to try. So I want you to take a minute and try this, and then we'll talk about it.
Knowledge.
Okay, what is the probability of rolling a 6 when rolling a 6-sided die? How do we write this with the letter P? Caitlin?
I did P with odd this time.
Oh, but it doesn't say odd. It
It
wants-
would be P odd.
No, it doesn't want to know the probability of doing
P6.
P6. There we go. We want to know the probability of rolling a 6. Okay, now possible outcomes are the same outcomes that we had before. There are 6 outcomes. We could roll a 1, a 2, a 3, a 4, a 5, or a 6. Fix my 5 there. I need to write a little slower.
2, 4, 6,
Okay, 5 or
8.
6.
2,
How
4.
many of those numbers are the one that we want? Spencer's got a finger in the air. 1. There's only 1 6, right? So there's only one favorable outcome, which is the 6. So the probability of rolling a 6 is 1 out of 6. There's 1 6 out of the total number of numbers on the die. So 1 over 6. What does that work out to be as a decimal?
0.1.
0 point what?
6.
0.16. Repeating. What would that be as a percent?
16%.
We'd round it probably to 17% because the next one will be high, so it'll be 17%. Okay, let's look at the next one.
I got it.
This one says, what is the probability of drawing a vowel out of a bag of letters that contains one of each letter of the alphabet? So how would I write the event? The letter P, what would I put in
How many
there?
vowels are there? P would be 6. P.
Let's wait, we'll talk about how many vowels in a minute. Don't make this too hard, we just want to know
P5.
probability of, so we don't need a number.
P. A vowel.
Just the word vowel.
Vowel.
So we're finding the probability
Vowel.
of getting a vowel.
Bro.
Okay, how many letters are in the alphabet?
I don't know.
Spencer?
26.
26. So
How's
there's
there
26
letters in the alphabet?
A, B, C, D, E, F, G, H, I, J, K, L, M, N,
I don't
O,
know.
P, Q,
There
R,
are
S,
26.
T, U, V, W, X, Y, Z.
No, first
Skipped one
grade.
somewhere.
It's like
So there's
second grade.
26.
First grade.
Now, favorable outcomes, that's how many vowels are there?
Four.
Yeah, you counting Y would be 6.
Yeah, we're not going to count Y, so we'll just stick with the standard vowels, A, E, I, O, U. So there are 5. So the probability that we're going to draw a vowel is what?
5 over 26.
5 over 26, good. What is that as a decimal? I don't have this written down, so a couple of you do it so that we can check answers. Brian?
0.5? Yeah, I got 0.19. Well,
It's not 0.5, because 5 divided by 26 is not
No, that's not what I
0.5.
said. I said 19.
Good, 0.19. Just wait, guys, write this last thing, which is 19%. We'll start here tomorrow.
I don't know if we have.
Johnny.
Okay, we forgot to turn on the recording. So this is for you, Mackenzie. Hit pause and copy this page down because we already talked through it and we forgot to record it. Okay, I did not record this page for her. That's okay. Okay. Mackenzie, Caitlin is saying that she copied this down for you. Aren't you glad we're doing this just for you, Mackenzie? Everyone say hi, Mackenzie. Okay, now we're on. Shh, guys, I need quiet. Now we're on this page, so we're looking at the probability of drawing a red marble. There are 4 red marbles out of 25 total marbles. So we do 4 divided by 25. What do we get? Well, I want it as a decimal. Can you just do 4 divided by 25? Don't use your ABC button. Just do 4 divided by 25. Someone else do it too, so we have a check.
0.16.
let me see. 0.16. Okay, so we get 0.16.
Yeah.
What percent is that?
16.
16%. How likely is it that we're going to pick a red marble? Would we say it's likely or unlikely? Unlikely. So let's write unlikely.
Hopefully not.
Okay, and letter B is drawing a yellow or blue marble. When it says yellow or blue, it means either color is okay. We want to either get a yellow one or a blue marble. So, wait, we need to go step by step. Don't shut up. Okay. How many of the marbles are either yellow or blue? Marissa?
10.
Well, there's 10 yellow. How many blue? So how many is that altogether?
15.
15. So there are 15 marbles. Let me write this out. Probability yellow or blue. There are 15 that are yellow or blue out of how many total?
25.
Same. Okay, now do 15 divided by 25 and tell me what you get. 15 divided by 25. Caitlin?
0.6.
0.6. What percent would that be?
That would be 60%.
60%. So what are the chances? Would you say that's
Yes.
likely or unlikely?
Likely.
Likely. So we'll say that one is likely. Okay. Now we need to know the probability of drawing a green marble. Johnny, what are the chances that you're going to draw a green marble?
Unlikely because it's not even in the problem.
It's more than unlikely though.
It's not possible.
It's impossible. Good. There are no green marbles. So the probability of drawing green is 0
Technically not
out of 25, which is 0. So it is impossible.
No, it's not.
Okay, letter D says drawing a yellow, orange, red, or blue marble. How many of the marbles are one of these colors, yellow, orange, red, or blue? If we add up all the yellow, orange, red, and blues, what do we get? 25. So the probability of drawing, I'm going to say, any color is 25 out of 25, which is what percent? 100%. It equals 1, so it's 100%. So the probability of that happening is certain. Okay? If we draw a marble, it is going to be one of those colors. Not yet. Okay, last thing. The complement, and it's not spelled the same way as when you give someone a compliment, like if I said, Victoria, I like your dress. That's a compliment, but we spell that with an I, and this is spelled with an E. So it's like the word compliment when you tell someone something
I don't
nice, but it's
understand
not.
this
Oh.
English language. We have to say so much stuff.
That's not understand comments for.
Okay, guys, let's not get sidetracked. Stay with math.
No.
An event. Listen. An event and its complement always add up to 1. Okay, so here's an example. This will make more sense. If we want to know if the event is getting a multiple of 3, the complement is just the opposite. The complement is not getting a multiple of 3. So just a couple, I'll help you with that in a second. Just a couple oral examples. So we're not going to write these down. If I were to say, what's the probability of getting an even number on a die? What would the complement of that be? Johnny?
Wouldn't that be 3?
No, I don't want to know what it is.
Oh.
What's its complement? If I say getting an even number on a die, what's the
That would be
complement?
1. Oh wait, no, that would be
No numbers. What's the event that would be its complement?
rolling the die 6 times.
No.
What?
Okay. I don't think you guys were paying attention back on the example. The example is the probability of getting a multiple of 3. Its complement is the probability of not getting a multiple of 3. It's the opposite. So what's the opposite of getting an even number on a die?
Getting an odd one.
Getting an odd number. So that would be one set of complements. Let's make a little list of complements. Complements.
Ow.
So the probability of even and the probability of odd would be two complements. Okay? What about if I said, what's the probability of having blonde hair? What would be the complement of that?
That
Wait,
awesome.
why would we have?
What's the complement? What's
So it's the opposite.
the opposite? What's the opposite of having blonde hair?
Yellow.
Having red hair.
Yellow.
No, more general. How about of not
Brown.
having blonde hair?
Brown.
Yeah.
But it could be any color, okay? Blonde is blonde and then everything else. So the
Blonde.
complement of blonde is the probability of not blonde.
What?
Okay, what about this? What about if I say the probability that you are wearing sneakers? What's the complement of that?
Not.
There we go. You guys are getting it now. It's the probability of not sneakers. Let's do one more. Let's do probability that you are smiling.
Not smiling.
Not smiling. You got
Smile,
it.
smile,
Good.
smile.
Probability of not. Gotta move this garbage out of the way.
To me.
Not smiling.
I don't like smiling.
Okay, now let's go back to our example. I think you guys have that. I need focus again.
Yeah, focus on.
Okay. For a six-sided cube, let's find what is the probability that you're going to get a multiple of 3. Let's see what the numbers are that we could get. We could get 1, 2, 3, 4,
5,
5,
6.
6. How many of those numbers are multiples of 3?
Billy.
3, 6.
3 and
No.
6. Okay, so 3 is a multiple of 3. Well, you guessed right. 3 is a multiple of 3. 6 is. So what's the probability that we're going to get a multiple of 3?
2 out of 6.
2 out of 6. Good. So the probability that we're going to get a multiple of 3 is 2 out of 6. Okay, so if the probability of getting a multiple of 3 is 2 out of 6, what's the probability that we're not going to get a multiple of 3?
4 out of 6.
4 out of 6. It's all the rest.
Yeah.
So if 2 out of 6 are multiples of 3, that means the other 4 were not multiples of 3. So this is 4 out of 6. Okay, let's look at the next example. If the probability of spinning a 6 on a spinner is 1 out of 10, what's the probability of not spinning a 6? If there's 1 6, how many numbers are not 6?
That would be
Sammy?
4.
5.
It's, wait,
Diana.
Just on like a regular spinner, like just casual.
Okay. On the spinner,
9.
the probability is 1 out of 10. That means on the spinner, you know how you spin a spinner on a game like on Life? You spin that thing and it goes around and
Yeah.
it hits the numbers? Okay. There's 10 numbers on the spinner. One of them is a 6, so how many are not 6?
9.
9. Yeah, if one is 6, the other 9
I
are
was
not
close.
6.
I
So the
said,
probability of not spinning a 6 would be 9 out of 10. What if I said, let's do some other what ifs. What if I tell you that the probability that someone in here is wearing dress shoes is 2 out
Too
of
much shoes.
2 out of 9.
Any shoes.
Okay, the
2
probability
out of 1.
Hit them all, Johnny. Stank.
of wearing dress shoes is 2 out of 9. This means that 2 of us out of the 9,
Wait, wouldn't those be considered dress shoes?
no. Victoria and I both have, Victoria,
Oh,
show them your
yeah.
shoes. We have dress shoes. These are called dress shoes, okay? That's what I had in mind, like ladies' dress shoes. So what's the probability of not dress shoes?
A lot. 1, 2, 3, 4.
What's the probability of not dress shoes? This
Six.
should not be hard now.
5. Wait, no, 4.
How many people are in our class?
Listen,
7.
2 people out of 9 are wearing dress shoes. How many people are not wearing dress shoes?
7.
7. So it's 7 out of
No.
9.
The muscles are huge.
Okay, let's say the probability.
Oh yeah, that's who I sketched.
Listen,
can't say.
Let's say the probability that someone ate pizza for lunch is
Million.
2
Out of
out of 5.
Million.
100.
Wait a second, I did that wrong.
3 out of 5 then.
The probability of not pizza then
3
is
out of
what?
5.
3 out of 5.
Five.
Does everyone see why that's true?
Yes.
2 out of 5, there's 3 left, so it's 3 out of 5.
100.
Okay, I think that was our last.
Yes, it is.
All right, exit ticket. I want you guys to do this, and then I will give you your assignment that you're going to work on for the rest of class.
Bye, Matt.
Bye, Mackenzie.
That